As we begin to talk about animation, I want to draw a contrast between two different types of images. What you see on the screen right now, I would call a static image. We can contrast that to the dynamic image you now see on the screen. So when I say static, I mean the kind of image that does not move. It stays the same, there's no change. On the other hand, dynamic images move and change over time. So all the art we worked on so far has been static, but now we're going to start talking more about dynamic forms of art. So let's begin with the most important question. What is animation? Maybe when you think of animation, you think of a character like this. Or maybe you think of characters like these. You'd be right in both cases. Wikipedia says animation is the rapid display of a sequence of images of 2D or 3D artwork or model positions in order to create an illusion of movement. So let's think about what that might actually mean. If we look at this image of the bouncing ball, we can see that it's moving, it's going up and down, and it seems to be bouncing on the floor several times. Simple enough. But what that image actually consists of are 6 still static images. And if you look carefully, as one image changes to another, we see all aspects of the movement of the ball. It starts off flattened as it pushes against the ground. Then it goes back to its circular shape. It lifts off the ground, a little further off the ground. Now it begins to fall back down, hits the ground again, and then the sequence would start over and repeat over and over again until we get the bouncing ball. Now I'll show you a video I made using my camera. So I've got a very rudimentary animation going on here. Of course the can is not crushing itself, it's not moving on its own. What I've done is a very specific kind of animation called stop motion animation. And what I've done is I've taken a series of pictures with my camera, and each time I take a picture I would move the can or crumple it a little bit more. Then I took all of the pictures, put them together, played them, and what I got was the illusion of the can crumpling in on itself. Heading back to the definition here, animation is the rapid display of a sequence of images. So if I take a sequence of 6 images, like I saw in the bouncing ball, and I display them rapidly enough, quickly enough, I will create the illusion of movement. Now, illusion, of course, means that something is not real, because the ball on the paper is not actually moving. But when I flash those images quickly enough, it appears to be moving. Now this all works because of something called the persistence of vision. Basically, our eyes can't keep up with what's happening on the screen, and so our brain sort of fills in for us and creates this illusion of movement. And that is the heart of animation. Another example might drive home the point. You might think of a flip book when you think of animation. Check out this example. Now what we saw in that image was a very talented person had drawn many images of that shape, and each one was a little bit different than the one before it, and as he flipped through them very rapidly, it made it seem as though the image was moving. On the screen now you'll see an animation of a galloping horse. What that is several images of the horse at different points in its run, flashing very quickly to create that illusion of movement. Now, of course, we won't be drawing our animations because this is a digital art class. We have the computer to help us with these tasks. For our first foray into animation, we're going to use this great little program called Pivot. Now, Pivot is a stick figure animator, which means that we're only going to be really moving around a little stick figure. But it's going to help us understand how animation works and get an understanding of the fundamentals that go behind making an animation. So you can always check out this website. It's a good one where you can actually download Pivot. It's very small. We'll be using the 3.1 beta. So if you don't have that at home, you can go ahead and download it. Welcome to Pivot. This is a very simple interface. Most of it should make sense right from the get-go. Up top, we're going to have our frames, which I'll explain in a second. When we want to play or stop our animation, that's where we'll go. This is the repeat button, so to have our animation repeat or not. This is very important right here. This is where we control the frame rate, which I will explain in just a moment. This right here lets us change the background. We're going to just go ahead and stay with the black background, and the only figure we have right now available to us is Stickman. Here's where you can actually play around with Stickman. You could move him, center him, change the color. This number here refers to the size of Stickman. We could also flip him back and forth. What we need to do is press the next frame button. So now we have our first frame. What we're going to do is we're going to move Stickman just a little bit. And this gray outline is just there to show you where his arm used to be in the previous frame. So now I'll add a new frame, and I will move his arm just a little bit more. And maybe I'll actually move his hand a little bit too. And I will do this several times in very small increments. Like this, and already I have 13 frames. Let's go ahead and press play and see what we get. Okay, it's repeating right now, so you see it over and over again. What we've got though is a set of pictures that we've made, each one a little bit different, that becomes an animation. Okay, so I'm talking about frame rate for a minute. Right now our frame rate is at 12. What that means is there are 12 frames for every second of video. Now if you watch him go through his motion one time, it takes just about 1 second. That's because all 12 of the frames that we have so far cycle through every second. If I stop him, unclick repeat, and press play, okay, that was about 1 second's worth of video. Now you can understand why animation becomes so time-consuming. The more pictures I have, or the more frames per second, the better my animation looks. High-end animation, like you'll see on TV, might have 30 frames per second. A movie might have 60 frames per second. The more frames per second, the better. I can adjust this slider here to determine how many frames I want to see per second. The smallest is 7. So if I put it on 7 frames per second, it should take him a little bit longer to go through his motion, but it will look a little bit jerkier. Let's try that. Okay. Like I said, it took him longer to go through his 12 frames, but he looked jerkier. As you move forward, I want to point out a few things that you should keep in mind. As I've made my examples for you to see, typically I've only moved one part of the Stickman at a time. Of course, you can always move different parts of him in each frame. Also, as you move forward and trying to animate Stickman, try and think about all of the small and subtle movements that go in to the things that we do every day when we do things like walk, jump, wave, and any other physical thing that you could think of. It might be beneficial to actually model for yourself in a mirror the actual motions that happen for these things. Finally, I want you to be very patient, because modeling these things can be very tricky, and some of the things that should be the easiest, we think, are actually the hardest. For example, if you decided that you wanted to have Stickman walk across the screen, you'd find that having him walk is one of the most complex things that you can do. There are a lot of movements that go into walking. Also keep in mind that Stickman can move his entire body. The final thing I want to point out about Pivot is that when you're done working, you should go to File and Save Animation. The important part though is you can save Pivot in several different formats. If you save it as a Pivot file, you'll be able to open it up later on and work on it some more. However, if you send it to somebody who does not have Pivot on their computer, they will not be able to view it. Instead, if you save it as a GIF file, it will play on anyone's computer, but you won't be able to open it up anymore and work on it. That's how you'll save it for me when you turn in your assignment. Keep in mind that AVI video does not actually work. That's a feature that was never quite created the way it was supposed to be. So the two that you should think about using are pivot files and GIF files. For those of you in my class, here's the assignment. You're going to animate Stickman to do a simple movement, nothing too intense. This animation should last 5 seconds. Now if there are 7 frames per second, and it should last 5 seconds, that means there should be 35 frames. Save your Stickman animation as a GIF file like I showed you, and send it to me on Edmodo.